We are live. I'm Sub 3.0, and today I'm speaking with Adrian Brink, who is the co-founder of Anoma, and we're going to be diving deep into Anoma and Namada. These are projects that I have yet to really fully get a grasp on, and today I'm hoping to get to the bottom of it and put a nail in this coffin once and for all. So we're going to be diving deep into Anoma and Namada, how they work, and I'm also dying to find out why Adrian thinks that what we're currently building isn't actually Gen 3 of blockchains, but still in Gen 2. Before we get started, please make sure to hit the notification bell, hit the like button, and subscribe to get notified when new live streams start every week. My guest, Adrian Brink, is coming up next, right here on the Interop. Hello, sir. Sorry, there's some weird noise going on, like someone's drilling something through the wall right now. How you doing?
Good. Yeah, no, can't complain. Currently not traveling anymore, so very happy to sit at home and focus.
Yeah, no, I definitely feel that as well. I just got home yesterday, and I've got a couple more trips in the next 2 weeks, but yeah, some short ones. So.
Yeah.
But maybe maybe before we start, what's your take on everything that's going on with FTX and Alameda?
I'm sort of surprised that FTX collapsed. I have to say I didn't think they'd be running a massive Ponzi scheme in the order of $10 billion. That always seemed somewhat unlikely. With Luna, we knew 3 years ago, kind of when the Terra white paper came out, that this was an algorithmic Ponzi scheme, effectively, that at some point it was going to go to zero, right? People read the paper and they looked at and thought about this for a week, and we did this in the Cosmos office back in 2019 in Berkeley, and we're like, okay, this is going to go to zero at some point. With 3 arrows, and now with FTX, it feels like, no one did any reasonable amount of due diligence. People just wired them billions of dollars, and we're like, yeah, that's fine. What's the worst thing that could happen? We're giving a 29-year-old in the Bahamas $2 billion to run a cryptocurrency exchange.
Yeah.
Yeah, so I don't know. This seems like we should really move away from centralized finance institutions. And I'm hoping we're getting there next year, actually.
Yeah, I mean, it's insane that collectively the industry has, in many, DeFi is significantly large, right? And but it's insane that as an industry, so many years in, people are perfectly fine with leaving their money on centralized exchanges and getting into these kind of leveraged sort of activities on exchanges with little transparency. And it seems to me this is what DeFi was meant to solve, but in the meantime, we've sort of rebuilt the same systems as in TradFi, but only, now it's with crypto.
So I would say actually the problem is currently we can't solve this in DeFi. We can't build something like a centralized exchange in the current generation 2 architecture of blockchains. What you mentioned in the intro is sort of, I think, very applicable here, which is what blockchain, when you look at most modern applications, what they actually need is decentralized counterparty discovery, because we don't want to settle everything in consensus. And sort of Uniswap is the most gas efficient way to do counterparty discovery in consensus. But when you think on someone wants to have an order book exchange, someone wants to have large multi-sigs, large multi-party voting systems, or second price auctions, kind of these kinds of things, they don't need to not every individual action needs to go into consensus, right? We need to you and me want to trade, and we sign our messages, and then we net this out with 50 other people, and then we submit this into some underlying settlement system. This is the right model to build pretty much any dApp right now without centralized backends. And so this is what we're building with Anoma, which is why I think and by the way, we're not the only people. In the next year, there will be more people building this kind of architecture. But if you want truly decentralized applications, this is the thing you need. You need decentralized counterparty discovery and distributed solving to enable this kind of intent-centric model where users don't send transactions, they send intents to other people effectively.
Yeah. And so in the model that you're describing, a lot of the So in the current paradigm of blockchains and the way we thought about blockchain so far, going back to Bitcoin, everything is settled on chain, and there's this transparency of traceability of like state transitions. What you're describing is something where a lot of the activity is happening off chain, but it is then sort of settling or proving back to some sort of a shared, some sort of shared data set that we can all verify.
Kind of, yes. It's, I think, still more fundamental in this. Like in all existing systems, we've always thought of transactions as the most fundamental unit, right? So like a user interacts with a system and they send a transaction. This is how you interact with Uniswap. This is how you interact with Aave. This is incidentally not how you interact with OpenSea or Optimism or Starknet. But so in the current Gen 2 model, everything is a transaction. Users are supposed to sign and submit transactions. But transactions imply that users have access to the entire state change. But when I want to trade some Bitcoin against ETH, I don't have access to the counterparty. I don't have access to the guy that takes the opposing side of this trade. So I don't actually have a transaction that I can submit into consensus and have ordered and settled somewhere. I have an intent. Like I have a thing that if you combine it with other things, we can combine into a solved solution and then submit as a transaction. And I think this is really the model we're heading into, because you see this like, what is a rollup? A rollup is just someone wants to go from state A to state B and another person wants to go from state B to C. And so what individual users do, they sign over their partial state transitions or their intents. And then the rollup sequencer takes all these intents and does some compute. And so like you see this everywhere. This is always the same model. 90% of all dApps currently have intents, but they have an architecture which cannot express them. So we always fall back to like, oh, we have an architecture that can't express intents and they can't really deal with intents because it doesn't understand what an intent is. So let's build this backend server run by the OpenSea company to do this. And then we are centralizing all of this. And I think sort of FTX is way more centralized than this, but this is fundamentally the problem, that it's very hard to build truly decentralized applications right now.
Yeah. Okay. So let's get into this intent-centric, model. And so we're gonna talk about Anoma because I think it's the foundation upon which Namada is built. So you guys have been building Anoma for some time now, and you're soon going to release like the first layer 1 that leverages Anoma. So I want to first look into how these two things are related, but then I want to spend most of our conversation actually talking about Namada, because I feel like there's some kind of confusion around what Anoma is, but once we describe the product, I feel like it's going to be clearer. But first, I want to read the description of Anoma from the documentation. Okay, so it says, Anoma is a protocol designed to facilitate the operation of network fractal instances which intercommunicate and can utilize varied state machines and security models. A fractal instance is an instance of Anoma consensus and execution protocols operated by a set of network validators. Anoma's fractal instance architecture is an attempt to build a platform which is architecturally homogeneous and with a heterogeneous security model. Thus, different fractal instances may specialize in different tasks and serve different communities. Privacy should be a default intent, should be default and inherent in the system we use for transaction. Adrian, what the fuck does that mean?
Okay, so Anoma is innovating on a lot of different areas, let's say it this way. And so trying to put all these things into a single sentence is quite hard. But let me try and unpack this a little bit. The first thing to understand is Anoma is an architecture. It is not a specific blockchain. Anoma is fundamentally an architecture. It's a protocol. And sort of the way we view the world is going to be multi-chain. And there will be many different security models, right? Like some people care about ETH2 global security. Some people will want to care about global Bitcoin security. Other people will care about their local 15 people in their village security model. Other people will want to be in their country in the national security model. And Anoma is an architecture that can be deployed into all of these. So you can deploy Anoma as a global L1, which is what we're doing. We're also working to deploy Anoma as an L2 to Ethereum. I spoke to Charlie Shrem yesterday about deploying Anoma as an L2 to Bitcoin. if a country wants to take Anoma as a protocol and like run this for their financial system, I'm happy, right? Like, because from an end user perspective, what we want to enable is that users get homogeneous architectures, as in people don't have to always rethink how do they interact with these systems. They should have the same APIs, the same guarantees, the same feature set available to them. Because as a result, you can like take your phone and roam between these different security models. Because like the end user applications always talk to roughly the same kind of architecture. But we want different security models because different people care about different security. Right? Like my parents will never trust global ETH2. They trust their local 15 people in their village. And so we should enable homogeneous architectures but heterogeneous security models. And this is sort of just on the deployment side. And sort of then, oh yeah, go on. Sorry, before I...
No, so I wanted to ask about this, like, because I read this in the paper, and so the heterogeneous architecture means that we all share homogeneous architecture means that we all share the same architecture for building, other layers of abstraction on top, but we might have different ways to reason about security. I mean, that sounds great, but already by building Anoma, you're creating a space of, by adding another type of architecture, it's just contributing to the heterogeneity of architectures, because they're creating like a new architecture. And also, I think in a lot of, there are a few things where we have truly homogeneous architectures. Maybe TCP/IP and the internet was like a really good, like we basically achieved homogeneity there. But for a lot of stuff, it's not the case. Like even mobile phones, in the US, you have one standard, and like
mobile phones are very homogeneous. Like I bought this phone in Switzerland.
There's like 6 different standards.
That's true, but like I bought this phone in Switzerland, and this works in China, the US, South America, and all of Southeast Asia, right? Like I don't have to keep switching phones. Passports are another good example, actually, of homogeneous architectures. Like we have one global passport standard, but many different security models in which you can use it. As in different countries with different security models. It's like, it's a very convenient kind of thing. And like most of the internet is a homogeneous stack as well, all the way from TCP/IP all up to HTTPS. Email is another thing. Like email also homogeneous architecture. Like it makes our life very convenient. The problem, for example, with like current messaging apps is that they don't have a homogeneous architecture. So we're all stuck in this like, why do I have fucking 15 different messaging clients? I don't know. Because everyone wants to do their own thing.
Yeah, but Ben Thompson talks about this. I also listen to Web2 people, and he talks about how like the SMS standard should have been expanded to support like messaging apps, and so that all the messaging apps could have used the SMS standard, just the same way Gmail and all the mail clients use, SMTP or and then have features that are built on top, but that always kind of comes back down to SMS for interoperability between the different different apps. I feel like homogeneous standard. I don't know what are the qualities required or the things that are required to create homogeneous standards, but it feels like involvement by state actors maybe is a thing that might be common to all the things we've talked about so far.
I don't know.
I don't know. Like how do we
when I look at
what's required?
When I look at like something like IBC, I actually think the right technical protocols end up winning a lot of the time in the long run, just because they become the easiest to use over time. For example, maybe like you mentioned this earlier, why are we building a new architecture? Mostly because currently we have two types of architectures in the blockchain space. We have scriptable settlement, which is everything like Bitcoin, Monero, Zcash. This is all the same architecture. Litecoin, Monero. It's all the same thing, right? Slightly different, but roughly the same category of things. And if you end up in this kind of world where this is sort of the granularity in terms of how many people have a shared architecture, I think we're already starting to win much. And then we have the second generation programmable settlement. And this is everything from Ethereum until Anoma, effectively. This is like Nia, Avalanche, Solana. This is all the same thing. It's an imperatively executed VM that does sequential smart contract calls. That's it. But when you actually look at what people need, we don't need this imperatively executed VM, not to build truly decentralized applications. Because what kind of applications do people use? They use things like OpenSea. They use things like 0x. And in all these models, people individually sign messages that they send to some server. This is generally in the case of OpenSea, one server in New York. In the case of 0x, this is some relayer. In the case, like this also applies to like all the rollups, Optimism and Starknet. People sign a thing, they send it to a server. This even applies to Flashbots. So it's always the same model. People don't have transactions, they have some form of intent that they sign. And what Anoma really does, Anoma generalizes this idea of what is a generalized intent, how do you do decentralized intent gossip, how do you have economic incentives to keep gossiping onwards, and then how do you have solvers hook into this intent gossip to figure out, oh, these 3 things want to go into a rollup, they should be in a rollup. These 3 things want to go into an OpenSea trade, let me put these 3 things into an OpenSea trade. The problem is with the current architectures like Gen 2, they're just like, due to the architectural deficiencies, we always end up in these like centralized models where it's like someone has to run some AWS web service to make the actual dApp work. And we try to hide over this fact. But this is true from all the rollups to all the dApps currently on Ethereum, where like at some point there's a Web 2 server that does a thing. And in the best case, they can at least not steal your money, but in the worst case, they can definitely censor you. So by the way, I also think there will be many architectures like Anoma. So I think, to me, homogeneous architectures would already be fine if we just end up in a model where it's like many Anoma-like things. They don't have to be Anoma one-to-one. They just have to look like Anoma roughly with an intent-centric model, because it's the thing that allows us to build true decentralized applications.
Okay, so maybe I think one good way to think about this is to compare it to the existing model. So let's maybe walk through, like the existing VM model, the transactions flows, and like you mentioned like the transaction is the transaction is kind of the main thing that gets focused on in the VM model versus the Anoma model. Like, let's maybe like draw a picture of what these two look like, and then we can move on to Namada.
Yeah. At a very high level, when you think of how currently Ethereum executes transactions, or how Solana does it, or how Near does it, it's a user signs over the imperative execution trace, right? They sign over sort of an array of opcodes that they think is okay to run. And then these opcodes get to change state. So users sign over what they want to happen, as in they sign over the how, not the what. And then the system runs the how, and sort of the what is an end result that the user had no idea. Like the user hopes.
Sorry, what do you mean by the how? What's the how?
As in like every individual opcode that gets executed, right? In current, like when I send an Ethereum transaction, I sign over opcodes. This is what I'm authorizing. I'm not authorizing a specific state change. I am authorizing some execution flow. And all these systems do exactly the same thing. This is horrendous from a UX perspective, because I as a user have to audit every single opcode. And I have to know exactly the right execution flow to interact with my counterparties or with my other contracts. In the Anoma model, on the other hand, the model is users sign over the what, as in they sign over what state change they're fine with. Like in the abstract, it's like users in state A, and user signs over the fact that he is fine if his account goes from state A to state B. So if a more specific example is a user currently holds a Bitcoin, and they would sign over a state change that says, I am okay to hold 100 ETH if I hold 0 Bitcoin. And so they sign over this. And then the system can figure out, how do I satisfy this? This could be then there's 100 counterparties. This could be there's one counterparty. This could be there is sort of a cross-chain message involved. But the user doesn't care, right? Because the user just said, I'm okay with this future state. And as a result, UIs can display, like this matches the intuition that people have when they sign things. Like when my parents think of like sending a transaction, they don't think, oh, I'm authorizing these 5 opcodes to do a thing. They think, oh, I want to buy an NFT kind of thing, right? Like they think about what's the final thing that I want. And so this is sort of how Anoma's execution flow is incredibly different from every existing system. And once you have this kind of base where you say people sign over state changes instead of execution flows, you can say, okay, now users just don't send transactions directly, they send intents. And we gossip these intents around, and you can have I have Polkadot dot for Atom, you have Atom for ETH, and someone else has ETH for Atom. This is generally not settleable, except when you take all three together, right? So we initially sign our intents, as in this is what we want. And then we gossip them around, and other people in the network can figure out, oh, these three things are combinable. This is also how rollups work. Like with Anoma, you just get on-demand rollups, because if I have intent from A to B, you have intent B to C, a third person can just generate an intent from A to C and just does the compression effectively. So this is how the Anoma model is very radically different, but makes building applications significantly easier. Because when you're a dApp developer currently, you have to think on like, okay, I have to run the server in the backend that does some counterparty discovery so that all these people know who to trade with. I have to run a solver that combines all these things that are settleable and then settle them. In Anoma, you just have to define your intent format and the application, like the dApp on chain, and then the entire intent gossip, the networking, the solving. All of this is just taken care of for you. So like your job as a dApp developer becomes significantly easier. The last cool thing is, as a dApp developer, you can build new dApps on existing dApps. In the sense, like, let's say there are two NFT marketplaces in Ethereum. They don't share order flow, because the order flow hits a central server, like they hit the exchange A central server and the exchange B central server. In Anoma, none of this order flow is proprietary, like it just hits the intent gossip network. So I can build a new exchange frontend that leverages the order flow for these other two things. And by the way, I'm using here exchanges and trading as an example because it's easy to understand, but Anoma is just general. It doesn't know what an asset or price is. It just knows some state A can go to some state B, and it checks that this is correctly signed.
Okay, that's a lot. I mean, but there's a few things that I want to kind of clear up here, because I think it's unclear to me, and I think it's unclear to a lot of people. So like, Anoma, it's a standard. It's like a specification. It's also a code base. So there's actual like code that's written. For people who are coming at this from the Gen 2 paradigm, would you say that Anoma is kind of like an SDK that allows you to build blockchains in the same way that like the Cosmos SDK allows you to build blockchains?
No, Anoma is more of a application platform. As in, it
it's
allows
not a blockchain.
No, it is
not
a blockchain. So like, you can take
Anoma. It's not a blockchain.
You can take Anoma and deploy it as a blockchain. Like it's an architecture you can also deploy to other things. But so, for example, we deploying Anoma as the first global L1, and this is sadly for now still called global Anoma. Maybe over time we change the name. But there will be a blockchain that implements the Anoma protocol, sort of coming to you sometime next year. And their developers can deploy applications that leverage this kind of intent-centric design. So it's less like the Cosmos SDK. It's more like it's a blockchain with which you can do things. It's not a framework in which to build blockchains. But on the other hand, if you're World of Warcraft and you want to take this blockchain, run this for your local community, go ahead, fork the code base, deploy it with your own validator set, launch your own token for it. I'm happy about it because all these instances are interoperable with each other using IBC.
Okay, so when you say that Anoma will be deployed as a blockchain, you're not talking about Namada. You're talking about something else.
Yes, we're launching two blockchains.
Okay,
or the Anoma Foundation is, yeah.
So Anoma will be a blockchain on which we'll be able to launch other blockchains.
On which you can deploy applications.
Well, on which you can deploy applications, okay. And Namada is another blockchain that is separate from this other Anoma blockchain on which you will be able to deploy applications, but that leverages Anoma as an underlying infrastructure.
Not exactly. So it's going to use the same consensus. Because this is something we haven't touched on yet. We're working on something called Typhon, which if you're familiar with Tendermint, it's effectively Tendermint 2. It's like what Tendermint should be upgraded to over time.
Yeah.
It allows you this capability to have on-demand sharding, that you have two blockchains that run in parallel and they run completely independently. But if there's a large overlap in validator set, you can have synchronous blocks between these two chains or between any number of chains. And so we're calling this a fractal instance. So there's a global Anoma instance, and then if the World of Warcraft people take their own Anoma instance and deploy it, then you have two Anoma instances, two deployments of Anoma that are fractal instances. But they can interoperate. They can have synchronous blocks via Typhon. They can exchange IBC messages. My hope is that over time, the Tendermint systems also upgrades, like Osmosis also upgrades to Typhon, which would be cool because then you can have sharded things between Anoma and Osmosis and things like this. So this is innovations on many different layers of the stack.
Okay. I think I'm starting to understand like the interplay between both. And
then Namada maybe like Namada is just interchain asset agnostic privacy. It is going to be the sort of best privacy best privacy preserving system, which is launching, like we launched testnets this week, and it's probably going to go live like January next year.
Okay. So let's talk about Namada, and we've already been here for 25 minutes, but
wow.
Yeah, let's dive in here. So, what is Namada? So, the website says Namada is a proof of stake L1 for interchain asset agnostic privacy. I read that as it's a privacy preserving blockchain in the same way that we have like Zcash, or maybe something like Penumbra, where like it'll offer sort of similar properties and features.
Yes,
what's different about Namada and like say I think Penumbra is like a good, because we've also had Henry on like 2 weeks ago, but what's similar and different between Anoma and Penumbra? Yeah.
Namada, right? Like Namada is built on top of Tendermint. It's a custom state machine written in Rust. And it leverages your knowledge proofs. So it leverages an extension to the sapling circuit deployed by Zcash called the MASP, or the multi-asset shield pool, plus the convert circuit, which is a circuit that we wrote by hand. Namada is very simply put, it provides a unified shielded set for all assets on the interchain. As in, you can take your Atom, and you can take your Osmo, and you can take your ETH, and your DAI, and your CryptoPunk, and they can all live in the same shielded set, so that an external observer cannot tell the difference whether you just moved around one Atom, one NFT, or one DAI, or one Osmo. So to an external observer, this is completely indistinguishable which assets you're touching. And this is sort of something that has never been there before. I think sort of Namada is closest to Zcash, except that it's proof of stake with asset agnostic features, with the fact that it's asset agnostic, as well as incentives for the shielded pool. And sort of Namada to me is really it's like the obvious extension in terms of privacy technology that we should be building to provide end users with very flexible privacy guarantees. Like Zcash always had the problem that you had to opt into ZEC. And like, I don't want ZEC, I may care about Atoms or ETH or DAI. Like, I want unified privacy guarantees for arbitrary assets. And then when you look at things like Aztec and Tornado Cash on Ethereum, they're generally very expensive, and they generally don't have unified privacy sets. As in, I as an observer can tell whether you like moved some ETH around or you moved some DAI around. And as a user, I have to be careful about how I pay transaction fees, because I have to pay transaction fees in ETH. And in Namada, you sort of get the best of everything. You get a sovereign proof stake L1 that is asset agnostic, where you can pay fees in arbitrary assets, as in we're using the F1 reward distribution system that Chris and Dave from Osmosis wrote up back in like 2020. That sadly never got implemented in the hub, but it's an automatically compounding fee system that can use arbitrary assets for fee payments. So this is very quickly Namada. And then to Penumbra tries to do a lot of things. They try to be like private proof of stake, private governance, everything private. And Namada is much more tailored. It's privacy preserving transfers for arbitrary assets.
So when you say privacy preserving transfers, that's the core utility. Is that meant to sort of sit in between, like, let's say you want to move some Atom over into Osmosis. When you say privacy preserving transfer, does that mean you're just kind of sitting in between that transaction such that it is obfuscated, or
Yes,
is there like
so
another utility?
users can use this in a number of different ways. So users could, for example, use this to pay for coffee privately, right? Like you can use USDT and then actually pay for coffee every day privately using Namada. It could also be that you have some Atom and you want to sort of generate a clean address where this isn't linkable to your previous address in public. What we all currently do, if you have this utility need, we go through a centralized exchange, like deposit to Kraken, withdraw to your new address from Kraken, right? This is also something that Namada enables. So you could like take Atom, send it to Namada, send it around in Namada, withdraw it back to the Cosmos hub onto a clean address that is not linkable. In Namada,
you can do this with Penumbra as well. Like when I was talking to Henry, he was mentioning it.
I think this is going to happen. Also work for Penumbra. The other thing you can do is you can also in V2 use shielded actions. So with Namada, you can also you're going to be able to execute transactions on other systems over IBC.
Yeah.
So that, for example, because we figured out that we can generate unique NFTs for actions. So, for example, your LP position in an osmosis pool can just be a unique NFT on Namada. And when you want to do an action, you move this NFT on Namada, and then the chain over IBC executes some action on your behalf on osmosis. And then V3 is probably private bridges so that we can connect Penumbra and Namada for like unified shielded set.
Yeah, I think the idea of being able to sit inside within a private system and control assets outside that private system, I think is like one of the most interesting use cases for this stuff. And when I was talking to Henry, I was like, wow, that's like, it's so like basically you can sit in the shadows, execute your transactions on say Cosmos or Osmosis or on other chains. And there's no way to trace back like to actually who's executing those transactions and how they're related to each other. It's super cool.
I would say not sit in the shadows. I would say like get the same privacy guarantees as the traditional financial system. Like people should not be using blockchains right now. Like you leak everything. And like I don't think people realize this.
So what is like where does the intent centricity manifest in this? Because like when you're describing this, it just sounds like a blockchain where you're just like making transactions as we are used to. But
so Namada isn't intent-centric. Namada isn't intent-centric. No, this is Namada. It looks very similar to a traditional blockchain, except that it comes with incredibly good privacy set of features. The intent-centricity, that kind of generation 3 architecture, really comes with Anoma. And like there, you can do fancier things. In Anoma, you'll be able to do fancier privacy-preserving things like you have an intent and you only partially reveal this to the world, and then someone partially matches against this intent at the intent gossip layer, and then this still ends up being settled on some underlying system. So like Anoma really comes with intents, Namada just comes with incredibly good privacy guarantees.
Okay, I'm more confused now.
Like think of Namada, very simply, like think of Namada as the single best privacy preserving blockchain to have been launched effectively. It's going to be the single best privacy preserving system. It's going to like fix the sort of shortcomings of Zcash, the shortcomings of Tenor Cash and Aztec, and do all of this on the Interchain so that you can bring arbitrary assets from your own blockchain to Namada.
But if it's using Anoma, why isn't it intent-centric? And the bigger question, if this is like your whole spiel about how Gen 3 blockchains should be intent-centric, why is Namada not?
So for like actual dApps, things need to be intent-centric. For simple transfers, they don't necessarily need to be intent-centric, because a transfer implies that have all the sort of data available to make the transaction on chain. So really, you can think of Namada as the first payment, or like as a privacy-preserving transfer system within the Anoma ecosystem and within the wider Interchain ecosystem. But this doesn't mean that Namada is necessarily intent-centric. Intent-centric only really comes into play when you want to do more complex things like trading, or like DAOs, kind of like Gitcoin like DAOs, or like NFT marketplaces. Then that's when you need intent centricity. With Namada, it's really just it offers you privacy guarantees for asset agnostic transfers.
So you can't use Namada to build applications or write contracts or anything. It's just asset transfers.
Yeah.
That's it.
I mean, over time, the chain may get upgraded. So this is quite possible. But I think sort of at launch, the software you're currently working on, it's going to be very specifically focused on transfers.
Okay.
Oh, and another cool thing about Namada, it's coming with a convert circuit, which allows you to receive rewards for holding assets in the shielded set for longer. And you receive them privately. As in, you can deposit ETH into the shielded set, and then Namada as a blockchain may issue you rewards based on how long you hold your ETH in the shielded set. And these things aren't locked. Like, you can withdraw them at any time, and when you withdraw them, you can just claim your rewards this way. But all of a sudden you have because privacy is a public good, and now we can actually build incentives around giving, providing public goods funding effectively by providing rewards to people that contribute to this public good.
So what's the incentive then? The incentive of leaving your assets in there is that you're allowing or reducing the ability for actors to look at transactions coming in and out and determining, finding some sort of correlation there. It's essentially looking at tornado cash and analyzing incoming and outgoing transactions. If you incentivize people to leave liquidity there, it somehow obfuscates those transactions?
No, it just provides incentives. So providing incentives in a shielded world is very hard because you generally don't know what's going on. So we had to write a new circuit to allow this. And even then, you're still fairly restricted. The benefit of having more assets in the shielded pool for longer is that technically all these assets form a single shielded set. So as an external observer, you can see what's in the shielded set, but you can't specifically observe what's within the shielded set. You can just see that something is in this bag, in this dark, this blue bag full of assets. So if there's only one asset coming in, and then I take it out, and then you come in and put your asset in, that provides much weaker privacy guarantees. So this is why there are incentives to hold things in the shielded set.
So this is the multi-asset shielded pool. So it's like a pool of assets. You go in with Atom and you come out with, say, Osmo or something. And that's because you have okay.
So it doesn't trade, right? It doesn't mix things. I put an Atom in and I can only take my Atom out. Or I send my Atom to you and then you can take that Atom out. But it's not like I put an Atom in and then I take it out in Osmo instead. Yeah.
Okay.
This is just it's a very simple feature set to not
a one-to-one transfer.
All of DeFi makes privacy very complicated. And when I look at people in the real world, most people don't have the desire to trade shitcoins. Most people have the desire to buy coffee. So Namada just does privacy preserving transfers.
Well, so tell that to all the people who are on FTX. Okay, so then what is a multi-asset shielded pool? Because I think I was confused about what that is.
Think of Sapling, right? Sapling, the Zcash circuit. Sapling is a single asset.
I'm vaguely familiar with.
So think of this with the Sapling circuit, you can have a blue bag that has ZEC written on this, or that could have some other asset written on this, but you can only put in a specific asset, and you can only take out a specific asset. And so you can instantiate this over and over again. And this is kind of what Tornado Cash did, where you had one bag full of ETH and one bag full of DAI, but an external observer can see which bag I'm interacting with, whether I'm interacting with a DAI bag or whether I'm interacting with a ZEC bag. So they can tell that I'm moving some DAI around or some ETH around or some ZEC. But in the multi-asset shielded pool, all assets live in the same bag. And so I can even put a housing NFT or a CryptoPunk in there. And I can move this CryptoPunk, I can send this CryptoPunk to you. But an external observer can't see whether a CryptoPunk moved around or some ETH moved around. So effectively, in a multi-asset shielded pool, the high value but low volume assets inherit all the privacy guarantees from the low value but high volume transactions. It's the right thing, it's the right way to design privacy preserving systems, because you sort of get defense in depth that external observers can't distinguish which asset classes you're interacting with. Did I blow your mind?
I'm just trying to, yeah, like I'm trying to build a picture in my mind of like all the different pieces to this, and I'm struggling. I'm still struggling to do that.
So Namada, very simple, like you can move an asset over IBC or over the two-way trustless Ethereum bridge into Namada. Now you have an asset in Namada. Namada comes with cubic slashing, which is, or CPOS, cubic proof of stake, which incorporates cubic slashing as well as modern F1 fee distribution systems. And then within Namada, you can do transfers effectively. You can do transparent transfers, as in I can send some Atom to you and you can then take them back out over the bridge or over IBC, or I can send you some ETH and then you can take them back out over the Ethereum bridge. But then you also have the capability to move the assets into the shielded pool. And so I take some ETH and I put them into the shielded pool. And then maybe I buy coffee with this and I keep paying for coffee in ETH. But an external observer can't tell. Like they just see that someone is interacting with the shielded pool. That's it. And then when I'm done paying for coffee, I can take it back out and submit it back to Ethereum, and even can submit it to a completely new address on Ethereum where none of my previous coffee payments are now correlatable to my ETH on Ethereum or any previous thing I did on Ethereum. This is sort of at a very basic level what you can do with Namada, sort of in V1. And in V2, you will be able to control other systems, other chains, using Namada effectively. So you can imagine you can open an Osmo pool or participate, put in a LP position up in Osmosis from Namada.
Okay. Yeah, maybe let's talk about launch phases here. Chris gave a talk at ZK Summit in Berlin a couple of months ago, and he talks about these 3 launch phases. So there's like the sovereign chain for asset agnostic privacy, which is what we've been describing so far. And then there's like phase 2, which is bridging to other privacy chains like Zcash, Penumbra, Aleo, which we've had on the podcast, Aleo as well. And then later there's private bridges.
Yeah. And then there's the sort of next phase. So V1 really is IBC-based bridges and a custom two-way trustless Ethereum bridge. And the multi-asset shield pool. V2, I think, is most likely going to end up being shielded actions, as in private actions on other chains over the connections, over the IBC connections. And V3 is then bridges to existing systems, to existing privacy-preserving systems. And then V3.5 sort of is private bridging. Because the nice thing is, once you have private bridges, you get unified privacy sets. So like, once there's a private bridge between Namada and Penumbra and Namada and Aleo, it is very hard to determine where assets are currently being moved around. So you get a very big privacy set. And this is also why we're very interested in building a privacy-preserving bridge to Zcash, because Zec so far has by far the best privacy set.
Yeah. Talk about this trustless Ethereum bridge. How do you achieve that?
So trustless in the sense that you don't have to trust a third party, right? Like when right, we spoke about this and sort of what my controversial takes are before we started the podcast. When most people currently think of bridges, they think of things like, oh, I'm bridging via the Cosmos Hub, or I'm bridging via Wormhole, or I'm bridging via Axelar. And I would always call these things trusted bridges, because I've taken an asset that was issued on, let's say, chain A, and I want to move it to chain B. But if I move it via Wormhole or Axelar or the Cosmos Hub, now I also have to trust those systems. I have to trust the people that routed my asset because they're in my trust path. But when I say trustless bridge, I mean you only trust the chain that issued the asset and the chain that you're currently on. So with the Ethereum bridge and Namada, of course you have to trust Ethereum, because Ethereum can inflate your ETH. So sure. Ethereum can make your asset worthless or seize assets, right? There's nothing preventing this bridge from Ethereum doing arbitrary things to its own assets. And once you have this ETH on Namada, you only have to trust Namada, because the bridge is fundamentally run by the Namada validator set. So it doesn't bridge via some third party where you now, oh, I have taken this ETH from Ethereum to Axelar and then to Namada. Because now if Axelar fails, your money is gone, right? Like, this is important to understand. even though you have no interactions with Axler for most of the time. I mean, this is also true for the Cosmos Hub, but even if those systems, if those third parties fail, your assets are gone. And so when I say trustless Ethereum bridge, it means you only have to trust the system that issued the asset and the system that you're on.
It's trust minimized. I mean, it's trust minimized in the same way that IBC is trust minimized. You have to trust the systems you're on, but you don't have to trust the bridges.
Yes, it's exactly the same security assumptions as IBC, roughly. This would get easier once you have light clients for Ethereum, and also the ability to verify Namada or Tendermint light clients on Ethereum. Okay. But the other cool thing is...
But trust minimized bridges require instant finality, right? Like, you need to have finality guarantees to have trust minimized bridging. If you can implement this, why couldn't we implement IBC on Ethereum?
You can. Effectively, what Namada does, so Namada makes a different assumption. Every Namada validator also has to run a full Ethereum node. Namada validators effectively finalize Ethereum, and if they ever are wrong about like some block getting reorged, they are slashable for that wrongness on Namada. This is something like every chain could theoretically do this right now. Like Osmosis could just say that all the validators need to run full Ethereum nodes, and then you have exactly the same trust as to Ethereum bridge. The requirement to run Ethereum full nodes for a Namada validator goes away as soon as we have IBC verification or like fast finality on Ethereum, of Ethereum on Namada.
Okay. So the barrier for validators is on Namada is going to be, say, higher than like your regular run-of-the-mill Cosmos chain, because they also have to like run Ethereum full nodes.
Yeah, you also have to run Ethereum full nodes, but the nice thing is this architecture gives us the ability to bridge to systems that don't have fast finality. So like the way you bridge to, something like, for example, Zcash, is you also have all the Namada validators run Zcash full nodes. Like how would you bridge to Solana? You'd also have them run Solana full nodes. Like the system is very flexible. I am personally an IBC believer. Chris is the third co-founder of the bunch here, so like we're IBC maxis to some extent. But this kind of like bridge architecture gives us the ability to build bridges to systems that, like in a trust minimized way, that don't currently support IBC natively. Over time, I hope this all goes away and we can just use IBC, because then the Namada validators' lives get easier.
Okay, so no validators have to run full Zcash nodes, full Ethereum nodes.
At launch, only Ethereum nodes, don't worry.
Oh, okay.
This is only like...
Right. That's interesting. I mean, as a validator, like on a couple of Cosmos chains, like that's a huge...
Ethereum nodes aren't that bad to run.
Yeah.
If you can run a Tendermint full node, you'll be fine.
Yeah. I mean, you do have to sync them, and you have to have like disk space. It's a lot more disk space than, say, like...
It's not free, but it's like, it's not an order of magnitude worse. Sure. It's like 1.2 worse or something like this. This is, I think, sort of my take on this. But as a result, you get the ability that, like, on Namada, you get ETH, which is fully backed by Namada.
Okay. And then there some kind of, like when you're bridging assets, because it's not instant finality, there needs to be some time to finality or to like high probability of finality. And so therefore there might be like a delay. Yeah. Or, so like, how does that work with ETH 2.0? Because like with ETH1, like with proof of work Ethereum, there is like probabilistic finality. But with ETH2, like I'm not quite sure how that works. Like,
with ETH2, you should actually be able to use the ETH2 finality guarantees. And this is something that we're going to upgrade as well over time. So like currently, the way you do this for ETH is you just assume, let's say 200 blocks. It's not that much. It's like 5-10 minutes or something like this. But like if there's ever 200 block reorg on Ethereum, then the system reverts, because every exchange will have lost all the deposits. I think sort of Kraken waits the longest at 30 deposits for ETH, 30 blocks for ETH deposits.
I think it's 40, but something like that.
Or 40, it's like somewhere in there, sort of like 200 is very conservative. So you have some delay there, and then going from Namada to Ethereum, you also have some delay because you have to get the transactions into the blocks. one nice thing is that you can pay transaction fees on Namada for the relaying. So because from Namada to Ethereum or going from any system to Ethereum is relatively expensive because you have to verify a bunch of proofs on Ethereum, unless you sort of outsource this to some trusted third party like Wormhole, who hides the cost from users. So what happens in Namada is individual users can pay transaction fees, and then the relayer that submits this to Ethereum, if this gets executed on Ethereum, can claim the fees back on Namada. So there's economic incentives to have decentralized relaying from Namada to Ethereum, which is also cool. No one has bothered building this either. We all just hope that IBC packets get relayed for free, because currently executing IBC packets is very cheap. But for Ethereum, this is sadly not true. So you need some sort of economic incentive to relay packets from some system to Ethereum.
So this idea of running a validator is running full nodes. If it's so easy and if it solves a bunch of stuff, if it reduces the dependency on bridges like Wormhole or XLR, why do you think other Cosmos chains are not doing this? Why isn't Osmosis or Evmos or chains that have a clear incentive to be able to bridge assets in and out also implement this?
I suspect that a bunch of them will take our code base and effectively do exactly the same thing. There is, of course, a development overhead. We've spent easily 9 months building this. I think this is important. I don't want to have users rely on sort of third-party bridges, but they think they don't realize it's in their trust model. So I think this is sort of a choice that we've made, which I still think to this day is the right choice. This is one thing you need to remember about, I think, the team building Anoma is it's a 40 people team or 45 people team that has been building layer ones for 5 years at this point. There are very few teams that sort of have this kind of technical capacity and technical depth to build very complicated systems in terms of interoperability guarantees. I think without Chris, I probably wouldn't be attempting this either. The stuff is hard, as we've seen.
Yeah. So I want to talk about this cubic proof of stake and also maybe the governance, because let's talk about the governance first. So the docs mentions this off-chain signaling mechanism and an on-chain voting mechanism. What's the idea here?
So this is generally true for all systems. Every system will have an off-chain mechanism, right? If this entire system halts, there is usually some social recovery. In our case, we've just made this, added this into the client, so that when there is a need for off-chain coordination because the system halted, right? You can't use the blockchain for coordination anymore. At least you can still use the same keys to sign your messages, and you can receive signed messages and have your client verify the signatures from other people. So that instead of just having unauthenticated Telegram messages floating around on how to reset the chain, you can have sort of cryptographic guarantees on the people that are sending you these messages in social recovery have skin in the game. They're staked on the previous on the halted version. And for on-chain signaling, it's people can vote on proposals. There are simple text-based proposals. You can do also some automatic parameter upgrades using WASM. And so governance or validators can, users can effectively propose changes and upgrade this chain this way. I think one other interesting thing about Namada is it comes with I think we're calling this a governance council. So it's not just you can always do sort of global referendums. And then these global referendums that can be voted on by every validator. But we also wanted the ability to have fast-moving governance. So the global system can elect a governance council. And this governance council can be allocated some funds, and they can spend these funds pretty much either on a running basis or sort of on one-off governance proposals, where they don't have to clear every vote up to a certain threshold with the entire community, but rather can say, we want to fund this specific thing because we think it's a good idea. The governance council can just do this, which is, I think, the right governance model. I think having everything go via global governance is kind of a bad idea because it makes things very, very slow, and it seems very silly to involve sort of 2,000 people to decide how to spend $1,000 on like some conference sponsorship.
Yeah. Does this have any similarity to the sub-DAO model that we see on Juno and the council model that is due to be implemented in Atom 2?
Maybe. I'm actually not too familiar with Juno. I think sort of the biggest similarity maybe to Polkadot with the Polkadot governance council model. To be fair, like, I mean, we can all call these different things. It's effectively, I mean, it's how generally like governance tends to work. As in, we don't tend to make every choice via global referenda. We tend to elect representatives or governance councils that then can make choices. And you can recall these people and you can authorize them to spend a certain amount of funds. So I think it's really like, it's novel for blockchains, but it's not really novel when you look at humans. It's like the obvious thing I think we should be doing.
Yeah. I think with blockchains, there is a certain reluctance, I think, to institute sort of governance councils because, well, there is this idea on blockchains that like every participant has an equal vote and
they have an equal vote. I think every participant has an equal vote in deciding on the governance council. And every participant can still have like, you can like, this doesn't preclude the idea to have global referenda, right? This only means that sort of the happy path can be much more streamlined because I don't have an opinion on like every single choice that gets made in pretty much any governance system that I'm part of.
So the paper also mentions this proactive and retroactive public good funding.
I mean, this is, I think one of the big tricks in governance is you have to figure out which people you want to actually have part of your community. So governance can decide to retroactively provide airdrops to, for example, early IBC users, early Zcash users. And then you can also have proactive public goods funding, which is, well, you're providing a block explorer. And this is actually the big thing. So most things currently, all governance systems are designed as one-off things. As in, there is like, here's a grant, now do a thing. Whereas in Namada, the governance as well as the governance council can allocate continuous funding for proactive public goods funding. So they can say, well, this dev team should receive X amount every month for 12 months. And so then you have this stability that you would expect from normal human relationships, where it's like, oh no, here it's not just here's a bunch of money, now please do a thing, but here you get a little bit of money every month, and if you stop doing any work, we can also take this back. So this is sort of the proactive side of things versus the retroactive side, because there are some things that we can't really fund in a retroactive fashion.
And this proof of stake, so this cubic proof of stake, what is that? And also, how does it relate to Typhoon and this Tenement?
So Namada V1 still uses Tenement core. So for validators, it's actually very easy.
Tenement, like Cosmos Tenement, everyone's using.
Vanilla Tenement, yes. Cubic slashing or cubic proof of stake mostly refers to the fact that the more people commit an infraction, the higher the slash is going to be, right? Like instead of the current model, which pretty much every Cosmos chain still has, which I think is horrendously insecure, that like you slash people for safety faults at like a constant rate of 5%. It's ridiculous. I think there are a number of chains for which it's economically the right choice to steal all funds that are bridged in, because the slash is a constant 5%. And I think, people should be very careful here. So in Namada, you don't have this problem because you also have bridged in funds, but slashes go up proportional to the number of people committing the infractions.
So cubic is just is only a way to effectively control, like the slashing mechanism is different.
It's a different slashing mechanism, yes. But we call it cubic proof of stake because it also fundamentally comes with a different proof of stake fee distribution model and reward distribution model. As in, there was this idea back in the day to implement this thing called the F1 fee distribution system or the F1 reward system, which enables automatic compounding of rewards, as well as allows transaction fees to be paid in arbitrary currencies. So Namada also implements this. I can send you the paper afterwards. This sort of a 10-page academic paper written by Chris and Dave on this.
Okay.
When is the paper actually? Setting this up.
We'll put that in the show notes.
Oh yeah, it's on 2019.
Yeah. Okay, so maybe just to sum up here, like Namada is a new layer 1 that does a multi-asset shielded pool and private transfers. It will at some point incorporate bridging between other privacy chains so that we have a larger privacy set, and then later private bridges and bridges to Ethereum.
Ethereum bridge is ready at launch.
Oh, Ethereum bridge, okay, but private bridging to other
That's V3
IBC chains. Okay, V3.
To other IBC chains, whether this private bridge is independent of the underlying bridge protocol, whether this is IBC or some other technology, it doesn't matter.
Okay, so I think that's quite clear now. Like at least Namada is clear to me, and I think one of the things I learned today is that Namada is not an Anoma, intent-centric chain.
Yes,
and that makes it much easier to understand, I think, for a lot of people who understand basically how blockchain works.
Namada is a very easy onboarding step into the Anoma ecosystem. Because Anoma is it's like Anoma is like the step up we did from Bitcoin to Ethereum. This is Anoma is the step up from Ethereum to Anoma.
Okay. So let's come back to Anoma, because you said something earlier that I wasn't prepared for, which you said that Anoma would launch its own blockchain, and that this blockchain, people can deploy apps here. So Anoma is a platform on which people can deploy applications. What do you think that's going to look like, and what kind of applications? What kind of applications will people build there, and is it also privacy preserving by default? And yeah, what are they using to build these applications? Can they just write them in any language, or they write them in Rust, or is it like Solidity?
So Anoma is just at the execution layer, it's WASM. So whatever you can compile to WASM works. There is probably going to be some inherent advantage in using Juvix, which is a dependently typed language that we are developing, because it allows you to build your intents as well as your validity predicates, and we're calling programs validity predicates in the same stack, and have the compiler enforce a bunch of guarantees across these things. I think so. This is how you can build them. Anoma is also, whether you want to use privacy preserving features or not is totally up to you as a developer, but the soft tech is there at the base layer. So Anoma comes with a circuit called the Tiger circuit, which is a recursive general programmability circuit in zero knowledge, as in you can have, it's the unified execution environment effectively. So you have a transparent part there. So if you don't want to use any privacy guarantees, you don't need to use the circuit at all. But the circuit by default gives you very nice computational compression. So for example, this is why I said you have on-demand rollups in Anoma, because if I just have some intent that goes from state A to state B, and you have an intent that goes from B to C, this doesn't both need to be executed independently. We can do an on-demand rollup, like any node in the intent gossip system can take these two intents, generate new zero-knowledge proofs for that rollup, and then submit the zero-knowledge proof to Anoma, and it's verified by Tiger. But at the same time, Tiger also supports the verification of privacy-preserving proofs. So you could have a private transaction that then gets verified by some circuit verifier within Tiger. So it's a very flexible system. I think the sort of first couple of applications that we're probably going to see are Anoma is an L1.5, so trying to decentralize or helping to decentralize existing applications on existing systems. Because fundamentally, Anoma does something that no one else does. It does decentralized counterparty discovery and distributed solving. Neither Juno, nor Evmos, nor Ethereum, nor Solana, nor Nia do any of this. Like, everyone just does programmable settlement. But so let's say you have an application on Evmos. Let's say you have an NFT marketplace on Evmos, actually. Right, there's still the centralized server in the background that gets all the NFT trades, matches them, and then settles them on Evmos in the end. So you can use Anoma as an L1.5, where you just say, well, we want to stay on Evmos or we want to stay on Ethereum for settlement, but we just want to decentralize this like central server that the core team is currently running. And we can put this on the Anoma intent gossip layer and the distributed solving layer. And so now we've decentralized our application, but it's still settled on some specific system that we care about. And I think so that
Okay, no, so Anoma would be like, one could use Anoma to do this counterparty discovery and solving, but still leverage blockchains like Ethereum or Juno or whatever to do the transacting. It's just that we're going to replace this. We're going to replace what a lot of blockchain, like a lot of the server stuff does, which is solving matching the trades.
And matchmaking and like counterparty discovery.
Okay.
And like, I know everyone keeps saying, oh, we have plans to decentralize these things. If you try to decentralize these things, you end up building Anoma. Like, if you actually really want to decentralize this, just read the Anoma specs and like build roughly the same system, because this is sort of the intent-based model is the right way to generalize this. I think this is sort of one stream of applications that I can see early on for Anoma. And I think the second stream of applications is just things that you can't build on any existing system. Like, Anoma ships with Fervio, so with Fervio you get programmable threshold decryption or programmable batching. It's a front-running, it's a distributed key generation protocol that allows you to have a single shared public key. All transactions or all intents are encrypted against a single shared public key. Then they are solved for or ordered, and then only once they are ordered are they submitted. And then like the solutions are encrypted as well, put into blocks. Once the ordering has been established, the validator can decrypt all of these transactions, and you can't front run them anymore. Like, this fully solves front running. But
it's like CowSwap.
Yes, but CowSwap does this with a central server. Because CowSwap has a central server that I send my transactions to, that solvers pull all the transactions from, and the server also enforces batching, and we have to trust the server to not inject their own transactions to front run other people. Like, you can build decentralized CowSwap, actually, which is something that you cannot build on Ethereum right now. Like, there's no technical way to build this on Ethereum. Because with Anoma, you get programmable batching. So an application can say, well, my batch period, so the CowSwap application on Anoma could say, my batch period is 100 blocks, whatever. And then intents are submitted, but they're encrypted against the Fervio public key. But the validator set knows, these are all intended for the specific CowSwap application, the specific CowSwap validity predicate on Anoma, and we should keep them encrypted for 100 blocks. And then after 100 blocks have passed, the validator decrypts all these intents that were destined for the CowSwap validity predicate. So now the VP can say, okay, let's give solvers another 50 blocks to produce a solution. So the solvers can grab all the now decrypted intents, but they can't inject their own anymore because we have a public record of which intents are in a batch without requiring a central server. So now the solvers look at this and go, okay, what is the optimal solution? And here again, the VP on Anoma can enforce optimality criteria. Whatever this may be. For CowSwap is everyone gets the same clearing price, and the best clearing price sort of is the most optimal solution. And this is also enforced on chain. Like currently in CowSwap, this is enforced by the server. So you can build these kinds of things, and like with these kind of primitives, you can also build truly private second price auctions where like all bids are encrypted until the auction period is over, and then they're decrypted, and then someone submits a solution to the auction. You can build on-demand rollups with this. Anoma is very versatile. You can build many things that you can also build from Ethereum, but in a full decentralized manner. But there are also some things that you just can't build on Ethereum right now because generation 2 architectures just don't support this model. Yeah.
Okay. Well, this is interesting.
It's a lot of stuff, I know.
Yeah, there's a lot.
Innovation is hard, but like I think this is really going to be. Yeah, I'm very excited. There are going to be a bunch of people, I think, working on Anoma like architectures in the coming years, because it's the right model. Like the Flashbots people have realized the same thing. They're like, how do we do this in general? It's like, yeah, this looks very similar to Anoma. So we'll see more of this. Generation 3 blockchains are coming.
Cool. Well, I think the last thing I wanted to ask about, and maybe we can also talk about, say, the roadmap here and what are the next steps, is you guys are currently running a trusted setup. What's this trusted setup for? And one thing I was thinking about also is, a lot of projects have done trusted setups. What is the reason why we can't just like leverage one big trusted setup instead of having to do one every time? Are there specific things that the trusted setup does for the project that aren't replicatable?
Yes, so we're currently running a trusted setup for Namada. We are reusing the powers of Tau, so the phase 1 of the Zcash sapling trusted setup.
Yeah.
The problem is, so like with Plonkup, you'd get universal trusted setup, but all our circuits for performance reasons are written against Groth 16. So there you can take sort of the phase 1 from, let's say, Zcash, as long as your circuit is under a certain limit. But you have to run a second phase in order to specialize the trusted setup for your specific circuit. So we can't get around this, because we have 2 new circuits effectively. Anoma does need a trusted setup, by the way. Anoma comes with a circuit, but it's using Halo 2. So we
What's Halo 2?
don't. It's another proof system that doesn't require a trusted setup anymore. It's effectively a Stark, but it was developed by people in the US, so it's called a Snark. As a funny side note, the difference between a Snark and a Stark is whether it was developed in Berkeley or in Israel. That's like the only difference. Like this is a pure marketing thing, whether it's a Snark or a Stark. They are very unified nowadays. So yeah, this is coming from Namada. So the trusted setup is starting, I think, in 2 weeks. We've started the sort of external testnet on Tuesday this week. I expect that we'll probably open this up to the general public in the next 2 weeks or so. And then, so right now we just like Namada is mostly done. It's just like the last polishing touches, and we have a fairly regular release cadence every 2 weeks. So from now until at some point we'll declare mainnet probably early, so January, February kind of. Namada mainnet is coming, and then Anoma testnets are probably coming later next year. Sort of think Q2. I would estimate Q2. We're making pretty good headway there too.
Okay. And what's your call to action? Like, what do you want people to do after having heard this?
Join the trusted setup for Namada. Once the testnet is public, try all the interfaces, try the IBC connectivity, try the privacy preserving transfers. Really play around with Namada. And if you are interested in blockchain design or sort of want to get beyond these very centralized dApps that we currently have on Generation 2 blockchains, check out Anoma, join the Discord, join us on Elements or Riot. And I think we'll probably have testnets for you fairly soon for Anoma as well.
Cool. Yeah, looking forward to it. And we might also try to run some validators on a testnet.
Yeah.
Last question. Who should we have on next? Who's one person you think should be on this podcast?
You mentioned a bunch of interesting. I mean, I had someone from Mina. I think it'd be cool. I don't know if you had someone from Mina yet.
No, I don't know Mina so well.
Mina it's interesting.
It's also zero knowledge.
They also do a bunch of zero knowledge proofs. So I'd probably talk to someone from Mina. Some of the validators, I think it's going to be quite interesting to see how the entire space now evolves. That like Solana and Terra both collapsed this year, and I know a lot of validators made a lot of money with those.
Yeah.
I'd say Mina. If you like privacy stuff or like zero knowledge stuff, Mina.
I do like. I mean, I do find it fundamentally interesting, and I am extremely attached to the sort of values and the applications that privacy preserving systems allow. But I just feel like a lot of the stuff is unusable by most people, and we've seen that. Like
It's
people didn't
rapidly changing.
Well, I hope so.
Changing.
I hope so. But like people didn't like flock to Zcash when a lot of people do Zcash, but like it's not at all like as used as like Ethereum or Bitcoin.
I think the problem, this is sort of what I was hinting at with Namada and why Namada is groundbreaking here. Like Zcash had the problem that no one wants to use ZEC. Everyone wants to use DAI. Tenor Cash is the problem that like no one wants to pay fees in ETH and pay like high fees on fees for Ethereum. Aztec is super slow. Like it's an hour to transfer. It's like Bitcoin level speed. So like all these like privacy systems are like early on, but I think with Namada I think it's the next frontier actually, in terms of privacy preserving tech.
And what do you think of like state actor pushback or regulatory challenges here? And I asked the same thing to Henry's. Are you afraid of going to jail one day?
We're writing open source code, and this seems very widely protected. I have to say, I think blockchains aren't going to work without privacy guarantees, because like if you're the NSA, the biggest threat to your national security is the US financial system being on transparent Ethereum tomorrow. Because then China runs financial surveillance on every one of your citizens, right? Like we could make the assumption that blockchains, maybe it was the wrong thing, but transparent blockchains will never get traction in the mainstream for like obvious security reasons. And the other thing then then you have the choice. We could give a government a special key with which they can reveal all transactions, but the problem is governments aren't set up for this. These become central failure points, and the US government tried this with the Clipper chips in the 80s. So like what we do with Namada, we have viewing keys. So like everyone individually can reveal one hop back, one hop forward. So if you need to interact with someone and need to reveal a transaction history, you can, and you should. Like this is to keep yourself not hidden from your government, but to keep yourself private to the same extent that the existing financial system is private. And sort of on the privacy coin thing, everything is a privacy coin.
Yeah.
ETH is a privacy coin by like any stretch of the imagination because you can put ETH into Interchain Cash. General programmability is going to destroy this model as well. The interesting thing, we didn't talk about this with Anoma, but with Anoma you can... So currently with sanctions, for example, you have to have one global enforcement, like one global block list. So like Ethereum is now enforcing US sanctions for a lot of things. With Anoma and Intents, you don't have to do this. You can say, like, I'm maybe sitting in Switzerland and I care about Swiss sanctions. So when I issue my intent, I can specify which sanctions list I care about. Right. So Americans would need to include the American sanctions list. UK people would need to include the British one. I would need to include the Swiss one. But like this is like the current systems don't work this way because they're sort of like these Gen 2 blockchains aren't flexible enough to support this. But like if you want a real world traction, we need these Gen 3 systems that give you this ability to where everyone individually says what kind of features they care about and what kind of guarantees they want for their settlement.
This is the condition. Sorry. These are the conditions that you would put in. Like when you're making an intent, you say like, I want to have 100 Bitcoin and 0 ETH. And also, I don't want to interact with any of these accounts or anything.
Exactly. Maybe you care like, I only want to interact with this whitelist, or I don't want to interact with anyone on this blacklist, or I don't want to be settled on Ethereum. This is like the right model because the current model is never going to scale to like world blockchains because at some point Europe is going to go like, why are we all enforcing US sanctions? This is silly.
Well, we'll have to leave it there. This has been really interesting. You've certainly opened up my understanding of Anoma and Namada. I feel like I've gained at least 50% more understanding than I had before. So maybe if we do it again in a few months, once things start going live, maybe I'll reach 100% understanding. And I hope our listeners also gained more understanding. So thanks so much.
Cool. Yeah. Thank you for having me.
Yeah, it's been a pleasure. And to our listeners, thanks again for tuning in. I do live streams every Thursday. So if you're interested in finding out more about what's going on in the Interchain ecosystem and staying up to date on the newest technologies, this is definitely like a technical podcast. And so we do technical shows, and so I want to like go deep and understand stuff technically. If you like that, please make sure to hit the notification bell, hit the like button, and subscribe to get notified when we go live every week. Thanks again. We'll see you next week.